Okay, hello guys. We'll be waiting for about 5 minutes and just waiting for people to come in, and then we'll get started. Okay, we can get started now. So, hello, I'm Wesley. Today I'll be presenting on the Mmaths competition. Let me just share my screen real quick. Okay, so um, so today I'll be covering Mmaths, which is a competition called Math Majors of America Tournament for High Schools. Um, And yeah, so let's get started. So before we begin with covering this competition, I just want to say a quick thing that our um, Logistem or the Gauss Math Tournament is coming up, and the Science Challenger is also coming up. It's going to be the weekend of June 7th. Um, every year, it's pretty fun. Lots of people come, and it's generally just a really good time. So I encourage you to sign up if you're interested in these fields. All right, so first, let's cover what is Mmaths. So Mmaths is a math competition, obviously, and it's centrally organized by a student organization at Yale called Yale Math Competitions, or YMC. So this is a competition that's based in Yale, but um, even though it's based at Yale, the competition is held at many sites across the country, not just Yale. So the first year I went was 2022. At that time, it was really just Yale and I think Texas. But as you can see, 2023, they extended to Michigan and Iowa. In 2024, there's even more places. So although you can see the list right here, it's predicted that in 2025, the list of schools that it's going to be at is going to be even greater, um, even though there's no list for sure so far. It's also been online this last year through MathDash, which I haven't personally used, but I heard it's a very neat website for learning math, and it's kind of similar to For the Win, but with more complexities added to it. So that sounds really nice too. So as you can see, they're growing really fast and expanding to a lot of places very quickly, which is always great to hear and a good sign about a competition's quality. Sorry about the text, by the way. I don't know why it's so faint. Oh, that's why it's so faint. Okay, so some more details about the competition. And although there's no set date every year, Mmath is almost always held on the last Saturday in October. So it's early fall, I guess. So for example, last year, um, Mmaths was offered on October 26th, but um, yeah, last year was a special case because of the PSAT, which was offered on the same day. So they offered a kind of condensed version on Sunday, the day after. But across the nation, it's almost always going to be late October or the last Saturday in October. So that's when you could expect it, and that's when you could start preparing for it. Um, Additionally, MS is not just an individual competition. Like many other competitions that have been talked about in previous seminars in this series, there's also team round. And in this case, teams can contain up to 6 students. Um, so even though teams can contain up to 6 students, that does not mean by any means that you need to have a team to attend this competition. So for example, if you don't have a team and you're just an individual, but you still want to compete in the competition, and you still want to do team round, there's options where the organizers can pair you with other individuals or other smaller groups of maybe 2 or 3 so that you can form as close to a complete team of 6 as possible with, I guess, people you don't know, but it's better than nothing. So it's a way to guarantee that everyone gets the ability to, you can't hear well? Okay, wait, sorry. Let's see. Uh, is this better? Can can you hear better now? Hopefully that works better. Okay, awesome. Awesome. Thanks for telling me. Um, yeah, so I guess as I was saying, um, to recap, it's always held in the last Saturday of October, so very late October, which I think is a very nice time, to be honest, because not only is it in the beginning of the school year where things are usually not very intense and isn't then and like things aren't building up as much, and there's no intense tests yet in school or anything like that. So you can relax and kind of just enjoy it for what it is. It's also the it's in like the middle of fall and it's really beautiful at Yale campus, especially, which is where I went. So I really think this timing is very good by the administration. And yes, there's a six student teams if you couldn't hear before. And they will pair you with other people if you don't have a full team, so you can still participate in the team round. And although you can have under six students, a full six student team is strongly recommended because of the difficulty of the team round. If you have less than six people, you'll be at a pretty big disadvantage because a lot of the team round questions are pretty tough. Okay. All right. So here's the format of the entire competition. So there's two, I guess I would like to call it main rounds, which are rounds that like everyone could participate in. The first is the individual round and the second is a team round. So the individual round is kind of similar. I like to compare it to Amy, although you can see it's obviously the timing and stuff is different, but it's 75 minutes for 12 problems. And in general, I would say the difficulty of these problems, the later ones, um, I would say I would really compare it to Amy. So about in the middle of the pack, it's probably around early Amy, maybe like Amy 4 to 7, I want to say, for the middle of these 12 problems. And near the end, it ramps up in difficulty really, really fast. So past like 7 or 8, it starts to get to like last three Amy level questions. So it's approachable because there's a wide range of problems, but I do want to say that the last questions, especially in recent years, has started to become much, much harder because of the amount of people that have been attending the test. Um, Now for team round, um, it's different than a lot of other team round formats in other competitions, but in this case, it's teams of six and it's 45 minutes for 10 problems. So it's um the fact that it's only 10 problems, but the later questions, of course, are harder. It ramps up in difficulty again, and 45 minutes is really not a lot of time. So you definitely have to be on the same page with your team and have a really good strategy going in, so you don't waste a single minute and you get everyone working on the strengths the entire time. Because if you don't, 45 minutes is going to run out really quickly. Um, Okay, now to determine the top placers, there's a tiebreaker round. So the individuals that are tied for eighth or above in the individual round will solve 2 to 3 problems in 10 minutes to determine the top 8 individuals for the Lightning Finals. So these 2 to 3 problems are usually extremely tough. A lot of the scores that I see in the tiebreaker round are 0 questions right. That's what most people get. Um, but the way to prevent a tiebreaker in the tiebreaker round itself is that they also account for how fast you submit your problem. So if you're the first to submit and you get the highest number right, then you're guaranteed a spot in the Lightning Finals. So obviously accuracy matters over speed, but that is how they break ties based on who submits first. Now we go to the lightning finals. The lightning finals is, if you've ever seen math counts for middle school, it's like the countdown round. So the top 8 individuals from the tiebreaker round will go head to head against each other on stage in the lightning finals. So 2 people will go up at a time, and there will be a question displayed on the screen for both of them to see, and whoever can solve it first, um, like hits a buzzer, and then they answer. If they get it wrong, the other person has a chance to answer. And I believe they may have changed the format, but I believe that for every matchup, like one person versus the other person, um, it should be best out of 3. So they solve 3 questions, and the person that gets the most of them wins. After 3 questions, if none of them have won yet, I think it goes to sudden death. So the first person to get a question right will win. And it keeps going like this with different pairings until finally they have a solid placing for everyone. And I do want to note that the individual round, team round, these are set in stone. These are pretty much unchanged throughout Mmaths history, and this is the format that they're going with. But every year they do change the rules and adapt to what they think will work better or feedback from the previous years. So there may be some changes to the way that tiebreaker or lightning round works this year. All right. So here's the typical schedule of an MS competition. So in the morning we have check-in, and these times are not set in stone. Every year the timing is different, and because they're also doing it in different locations, as I mentioned, multiple different locations across the nation, their timings will obviously be different. But this is just a sample, and it's usually going to be in this order. So first is check-in, and then the opening presentation. Then the individual round starts around 9:45 in the morning, and then that's immediately followed by the team round. After the team round, we there's a pretty long lunch break, and this is where you can wander the campus, hang out with your friends, talk to other people about how they did, all of that stuff. So lunch is pretty fun and chill. After lunch, there's usually a spotlight speaker, and this spotlight speaker can be almost anyone. This is also a break time. You don't have to go to the spotlight speaker, but I recommend you do because it's really insightful a lot of the times. Um, in 2022, it was um, some Yale students, including Luke, who I believe is pretty famous. Um, one of the greatest IMO winners of all time. Him and some other mathletes from Yale gave pretty much like a student panel for Yale. And then 2023, it was a professor who gave a talk based on like a specific topic he was interested in. I think it was tower powers or power towers. And then, yeah, so that pretty much sums it up. Every year it's different, but it's always really interesting and really fun to attend. Um, and a great way for everyone to kind of come together as a community at this competition. Then after that, we have finally the lightning finals. And the tiebreak round is usually during lunch. So those who place tie for top eight um, will be called to the tiebreak round after everyone else is done. Yeah, so then lightning finals happens, and then finally is the award ceremony. So these are just some pictures I'd like to share from my lunch break experience during Maths. I really want to highlight because not only is this a math competition, but you're also, I mean, if you're like me and you're living in the East Coast, it's also an opportunity to go to some really nice colleges. So Yale campus especially was really, really beautiful when I went in late October, as you can see, really colorful. Um, and this is a picture here, bottom left from the guest speaker presentation, and then top right, that's not actually from the Saturday that the competition took place, but the Friday before that, where we had like a get together or like a Friday fun night with all of the people, with my team and other people. Yeah. So, and I want to also mention that during lunch break, you're not really confined to the building that you're in. You can kind of wander anywhere as long as you're back by the time that you need to be back. Um, so we wandered like further into town and we got some food and stuff. So yeah, it was really cool. Okay, so now moving on to the actual questions. So this is what the test usually looks like. This is an example of the individual test. Um, as you can see, it's 12 questions. It's usually only one sheet long. Uh, and yeah. So now let's move on to some sample questions, the fun part. First, let's look at some sample questions from the individual round. And I'll be taking questions from the 2023 test because I think it's one of the most recent tests that they've released to the public. Um, and it's also the last one I went to. So as I mentioned before, individual round is 12 questions and 75 minutes. Questions increase and scale along with difficulty level. And the difficulty level does vary from year to year. This is very important because in 2024, so last year, the top 10 scored only 8 or 9, while the top 10 in 2023 scored 10 to 12. So as you can probably tell, they're getting harder and harder every year. So, and I'm assuming next year is going to become even harder because of the caliber of math students that are coming in. Okay, so here is question two. So this is the earlier questions. This is question 2 out of 12 of 2023. I'll give you guys a little bit of time to just read it and think about it for a little bit, and then we'll discuss. All right, so I think we can start discussing this one. This one's a pretty simple one. All right, so I'm gonna start annotating. So basically this problem reads, in the game of life, each square in an infinite grid of squares is either shaded or blank. Every day, if a square shares an edge with exactly 0 or 4 shaded squares, it becomes blank the next day. If a square shares an edge with exactly 2 or 3 squares, it becomes shaded the next day. Otherwise, it doesn't change. So on day one, each square is randomly shaded blank or shaded with equal probability. And if the probability that a given square is shaded on day two is a over b, where a and b are relatively prime positive integers, find a plus b. So it's only asking for day two, which means that we only have to do this probability thing once. Um, so let's look at one square in particular. Um, just draw this real quick. So let's say we're looking at this middle square, right? Now, we can separate this into two cases. Because on day one, each square is randomly shaded or blank, there's a 1/2 chance that it's either one. Let's start with the probability that it's blank. So if it's blank, we need it to become shaded. And that happens when there's exactly 2 or 3 squares that are shaded next to it. If it's one square that's shaded, it doesn't change and it stays blank. And if it's 0 or 4 shaded squares adjacent to it, it just becomes blank and stays the same again. So we need 2 or 3 squares. So first, let's look at 2 squares. Out of these 4 squares, how many ways are there to choose two to be shaded? The number of ways is 4, choose 2, obviously. Ooh, not a very good 2. Okay, and then for 3 squares that are shaded adjacent to it, obviously that's 4, choose 3. And this comes out to 10. And this is 10 out of the 16 possible different shadings because um, each each of the 4 adjacent squares can either be shaded or not for a total of 2 to the power 4, which is 16 choices. So that's 10 out of 10 over 16 probability that it stays that it becomes shaded when it starts blank. Now, for the other case, let's look at when when the middle square starts shaded. In this case, obviously, it can't be 0 or 4 adjacent shaded squares because it would become blank. But 1, 2, or 3 shaded squares adjacent to it would work. So that means that it's 4, choose 1 plus 4, choose 2 plus 4, choose 3. Oops. Sorry, guys, I'm using a mouse. It's quite quite hard to write. So that's going to turn out to be 14. And of course, we also have to divide this by 16 again because it's the same 16 total cases. So we have 10 over 16 for unshaded and 14 over 16 for blank. Now, the way we combine this is obviously it's a 1/2 chance that it starts blank. So that's going to be 1/2 times 10 over 16 plus 1/2 times 14 over 16, which it comes out to be 3/4. So our final answer is 7. So this is a pretty simple question, I'd say. Um, a lot of the times in Mmaths, what they do is they have a really interesting or like bizarre concept, or not really bizarre, but like a very grand concept, like an infinite grid of squares. And every day this happens, and it's like, oh my God, there's so much information. How do I think about an infinite grid of squares? But really, you just have to. I just find you have to be not intimidated by this concept, and in general, it simplifies into a really simple and pretty neat problem. Because even though this isn't hard, I still think this is a pretty beautiful problem. All right, next. Okay, let's clear this first. Okay, and this one is a little bit tougher, but again, oh, it's more intimidating than it looks more intimidating than it really is. We're gonna take couple minutes just so you can read it and get a feel for what it is, and then we'll dive in. All right, so let's start working on this question. So this is a question 7, so this is a little bit harder. I think past this point, the questions start to get tougher faster than before. 1 to 6 or 1 to 7, they're usually about the same difficulty. I don't want to say the exact same difficulty because it obviously does get harder. Um, but I want to say they're around the same, and then after that, there's a big spike, or maybe past 8. So first, let's look at this question. So 2023 by 2023 grid of lights begins with every light off. Each light is assigned a coordinate xy. Now, for every distinct pair of lights, x1, y1, x2, 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 y2, with x1 less than x2 and y1 greater than y2, all lights strictly between them, i.e., like so like think about a rectangle, right? So if these are the two corners, there's 2 points. Every point in between the rectangle you can imagine created by these two corners, um, is toggled. So that means if it's off, it turns on, and if it's on, it turns off. So after this procedure is done, for every single possible distinct pair of lights, how many lights are on? Okay, so first, instead of thinking about all the different possibilities we can have for every single combination of x1, y1, x2, y2, what we can instead think about is one specific point. So let's just take a specific point, xy. We just need to count how many times this XY light gets toggled. And notice that the only time it's toggled is let's draw like a dividing line here. Oh, that's not a line. So let's draw like a dividing line here. The only time XY is toggled is when it's in between the two corner points. And notice that x1, y1 is to the upper left of x2, y2. Because y1 is greater than y2 and x1 is less than x2, which means that for xy to be included between these 2 points, x1, y1 has to be in this area, and x2, y2 has to be within this area. And then every single combination of points where one of them's in the top and one of them's in the bottom, or top left and bottom right, will toggle x, y. So let's try to find an expression to do this. So for the top, we need to count how many different lights are there to the upper left of x, y. So obviously we can just do this by finding the area of the rectangle kind of. So obviously there's going to be x minus 1. That's going to be our horizontal side length because all the lights excluding x are counted. And then for the top, it's going to be 2023 minus y because 2023 is the total length and we're minusing y, which is the distance from the bottom. So this is the number of lights in this top left quadrant. And now we're going to do the same thing for this bottom left quadrant. In this case, it's 2023 minus x times y minus 1. So that's the number in this bottom quadrant. And note that every, as I mentioned, every pair of bottom quadrant, top quadrant will work, which means that we need to multiply these two. So we multiply all 4 of these terms, and that is going to be the number of times xy is toggled. Now, for xy to be on after this whole process is over, it has to be toggled an odd number of times because otherwise it's going to turn back off again. It's like if you toggle twice, it's going to go on then off. So we needed this expression, which represents the number of times x is toggled, or xy is toggled, to be odd. And the only way for this to be odd is if both x and y are even. Because of this x minus 1 term, this y minus 1 term here. So if they're both even, this expression will be odd. If only one of them is even, this will be even. And obviously both are odd, it's obviously going to be even as well. So that means that x and y both range from 0 or 1 to 2023. So for both x and y, there's 1011 possible choices because we need them to be even. Just 1011 even numbers between 1 and 2023. We have to square this because it's x times y, all the different combinations of x, y. And that comes out to be, I believe, I think that comes out to be 1000, 12121 or something like that. So again, this question, it really isn't like an intense bashing question or you have to like be smart with algebra or geometry or something like that. This question is really about seeing the underlying pattern and not being overwhelmed by this like huge 2000 by 2000 grid. So yeah, once you see the concept though underneath it, this problem is not too hard. You can see the calculation is pretty easy and it's really just seeing through the initial step. Okay, let's go through the final individual question we have, which will be question 9 from the same year. So this question is harder. You do have this time there is some more intense calculations involved. So yeah, let's take a few minutes to think about this and we'll get right in. Okay, let's get started with this question. So this one is a little bit tougher. It's a geometry question. So in triangle ABC, which with BAC equals 60 degrees, points D, E, and F lie on BC, AC, and AB respectively, such that D is the midpoint of BC and triangle DEF is equilateral. If BF equals 1 and EC equals 13, let's write that in. Then the area of DEF can be written as A root B over C, where they're all relatively prime positive integers, etc. So we basically need to find the area of this equilateral triangle. So the first thing we want to prove here is that let me outline it in a different color. But what we want to prove here is that this quadrilateral BFEC is actually cyclic. And we kind of have a good feeling about this to begin with because you can see that DF and DE are the same length, which suggests that maybe D is like the circumcenter of a circle, and F and E are both on the circle. So this is kind of an intuition type first guess because of the fact that we have a lot of 60s everywhere. There seems like there could be something we can do to create a cyclic condition and prove that this quadrilateral is cyclic. So the way we go about doing this is, let's assume that D is cyclic. So we just need to verify this. First, we know that this angle BFD, I should probably change the color back. So this angle BFD is equal to 120 minus this angle. So let me write that. Um, and this is because EFD is 60 degrees. But now notice that angle AFE is part of this triangle AEF, and with angle A equals 60 degrees. So 120 minus angle AFE is actually the same thing as just angle AEF. So that's pretty nice. And finally, since we are trying to link this to the quadrilateral BFEC, we want to link this to an angle within this quadrilateral. So we can express AEF as 180 minus FEC. Now, we need to verify this quadrilateral is cyclic. And to do that, first of all, we know that the opposite angles in a cyclic quadrilateral always add up to 180 degrees. This is a property of cyclic quadrilaterals. So in order F for this to be cyclic, we know that FEC plus FBD or FBC has to equal 180 degrees, which means that FBD has to equal FEC. And we all, or yeah, and we already know that, or FEA. We already know that this is equal to BFD from our earlier equality. So we actually know that in order for this to be cyclic, BD has to equal BF, or BD has to equal FD, sorry. And that's derived from this. Similarly, we can do the same exact procedure just on the other half of the triangle to get a similar result, which is that CD equals ED. And we verify that because DF is an equilateral triangle, ED equals FD, which means that BD equals CD, and therefore D is the midpoint of side BC, which is true given our problem, which means that this quadrilateral is cyclic. Another thing that we found through this is that BD and DC are both equal to the side lengths of the equilateral triangle from our result here, which is really important because it tells us that in this quadrilateral, D is actually the circumcenter. And that's because D is equidistant from all 4 points here. Not only is D the circumcenter, but BC is also the diameter of this circle. And from this, because we know that BC is the diameter, from the property of circles, properties of circles, what we can do is we can see that, maybe I'll use a different color, that if we draw these two, this line and this line, the diagonals, because they're on a circle and because BC as their hypotenuse is the diameter, we know that these are actually right angles here and here. Now this is huge because now instead of working with random triangles, we have right triangles to work with. And immediately we can see the impact of this. Um, because here we notice that ABE is a 30, 60, 90 triangle. Um, so let's draw an expression. We can use our side lengths now. We know that AB minus AF equals 1. And from the others, and we also know that because this is 30, 60, 90 triangle, AB is actually equal to 2 times AE. So this is the same thing as saying 2AE minus AF equals 1. Now we can do the same thing on the other side with triangle AFC. We can write a really similar expression. Since AC is twice of AF, we can write that 2AF minus 2AF minus AE equals 13. And with these two equations, we have two equations and two variables, so we can solve. And once we solve, uh, let's see, once we solve, we get that AF equals 9 and AE equals 5. So now we're pretty much done with the problem at this point. We basically have all the lengths we need and all the angles we need to find the side length of the triangle. And once we find the side length of DEF, we know the area. So from this information, we can use law of cosines on triangle AFE. Now, I won't bore you with the calculations, and I also really don't like writing with my mouse. But pretty much the result we get that is that um, side length of EF, which is the side length of the triangle, from law of cosines is root 61. And from that, we can find the area of the triangle. And pretty much we're done there. So I really like this question. Um, I I think it's really cool how you have to see through the fact that it's cyclic. This is my favorite type of geometry question. It's not really bashy. You just have to be smart and see through the simple tricks that are really hiding there in plain sight. And when you find them, it feels very satisfying. Awesome. So on time, we're running pretty low on time right now. So I do have a sample question prepared for team round. Um, but I just want to let you know that team round, similar to individual round, scales in difficulty quite a bit. You need to plan really well with your team to make sure you tackle all 10 questions in the 45 minutes because 45 minutes is not as much time as you might think. This is the question I was going to cover. Um, the style of this question, as you can probably see from just reading it, doesn't require computation, but just requires like analytical thinking and trying to plan or predict what the most optimal positioning is. So a quick summary. Um, the math at the Mmaths competition is fun and requires deep thinking. So although it's similar in difficulty to Amy questions, I do believe that the style of questions is not as computation intensive and is really more about like seeing through patterns and things like that. Um, Especially in the earlier questions. Obviously later you do need some more advanced math. Um, and the questions aren't very easily categorized, which is something I like. So like you can't really simply categorize every question into algebra, number theory, geometry, counting. Although for a lot of them you can, because there's some very unique and creative questions in there, like the lights one we just saw, or the tiling one we just saw, that I think they don't really fall into these strict categories, but they really do have very nice and beautiful solutions. And to get these beautiful solutions, you really need to rely on your like your analytical thinking or a specific revelation that you discover from like experimenting with a problem. And apart from the math competition itself, I think that the entire experience is really fun and relaxing, especially if you have a team of friends that you go with, because you do have a lot of free time to just explore and wander around the campus, take pictures, have fun, get food and stuff like that. So it's really just in addition to a math competition, it's a really big social event, and I think that's one of the most fun parts about it. Um, so we don't have much time, but if there's any quick questions, I can take them right now. So yeah. All right. So, oh, yes. So, sorry. Actually, the questions, let me just find that real quick. I'm gonna paste the link. So everything, a lot of things are available on the website. So this is the archive here. And this contains a lot of the past questions and solutions. So that's the link in the chat. All right, awesome. So if there's nothing else, then I guess we'll end it here. Thank you guys so much for attending. I hope this was really fun. I really think you should check out this competition. It's really fun, and personally, it's been a really great experience. So thank you guys so much, and hope you have a good day. Bye.